Okay, so today we're going to talk about exponential functions. It's going to be an introduction, and we're going to talk about what they are, what they look like, and what's the difference between growth and decay. So exponential functions are really important because especially now in this time with quarantine and everything, the coronavirus is growing at an exponential rate. So it's really important that we understand what exponential even means. So let's talk about that. So before we do this, we're going to talk about this do now and just evaluating this. 3 times 5 to the second power. A lot of people, when they see this, they're going to do the 3 times the 5 first. That's just because they see 3 times 5 and they're going to be like, okay, this is 15 squared. However, this is not the case because from our order of operations, right? PEMDAS or GEMS, whatever you use, we know that exponents come first. So technically, this is what we are to do first. So it's 3, the 3 stays, and 5 squared is what? 25. And then 3 times 25 is 75. Okay, so this is important to understand where exponents come in the order of operations here. Now, let's talk about what an exponential function is. So some words you need to know, we'll talk about them as we go. I'm going to give you guys an equation first. So if I have something like y equals, let's go with 5 to the x power. Okay, I'm going to draw this a little bit less obnoxiously. So y equals 5 to the x power. Okay, so the first thing you need to know is the base and the multiplier is, let's stick with the colors. The base and the multiplier is this number right here. Whatever is being raised to whatever power it is. So if I had y, the reason it's called the multiplier or the base is just because it's underneath the exponent, right? That's the b to the x. But why is it called the multiplier? Well, what's happening when we raise something to an exponent? I have y equals, like let's say it was 5 squared, like it was above. 5 squared is the same thing as saying 5 times 5. 5 is being multiplied, therefore it is the multiplier. It is being multiplied. So it's really important that, so if I have y equals 5 to the x, 5 is being multiplied by itself x times. So it's important to understand why it's called the multiplier or the base. And later on in another lesson, we're going to talk about it's also called the growth factor because it's at what factor it's growing by. But we'll get into that a little later. So that is the base or the multiplier. The exponent is pretty clear, right? The exponent is whatever it is raised to, whatever number or variable it is raised to. The exponent. Now, in an exponential function, and we are going to define it below, but in an exponential function, the exponent always has the independent variable in it. The independent variable is x, usually. Sometimes it's t, sometimes it's another, but usually x and t are the most common. Okay, so my independent variable and my exponent. Okay, now what is a coefficient or a starting value? We'll talk about why it's a starting value in a little bit, but right now we need to know it's the coefficient. The coefficient is if I had a number in front, so like 3. So 3 times 5 to the x. This is not the same thing as we stated above. This is not 15 to the x. It's 5 to the x multiplied by 3, multiplied by the coefficient. So the coefficient is up front right here. Okay, again, we'll talk about in another video why it is the starting value, so don't worry about that right now. And then the dependent variable is the y value. Dependent variable is y because y is dependent on x, right? So usually you'll see a word problem like, okay, if this is the equation and 5 years have passed, you plug in 5, and then what is the total? So these are just some vocabulary words. So this is the base or the multiplier, coefficient, exponent and independent variable, and then dependent variable. I will be using those words throughout the entire unit. So it's important that we understand what those are. What is an exponential function? An exponential function is a function whose independent variable is, I'm going to say is in the exponent. It is not always just the independent variable, right? So you can have something like y equals 5 to the 2x. That is still exponential. The independent variable is inside of the exponent. Versus a power function, right? So I'll give you an example. So we have y equals 2 to the x, or y equals 5 to the 2x, which I just did, right? Versus a power function whose base is the variable, right? So we've done power functions. Y equals x squared, right? That's quadratic. The base is the variable. Y equals 3x cubed. Coefficient, base, exponent, but this is a power function. It is not exponential because there is no variable inside of the exponent. So think exponential, exponent is in that word. So exponent, the variable is in the exponent. Okay, so let's look at what these look like on a graph, because you know I love Desmos. Judge me, it's fine. I get it. Singing is not my strongest suit out there. Okay, so here I have y equals b to the x. B for base. B will always be a base, right? So actually, let me write that down here. An exponential function is always written at the most basic level as y equals a times b to the x. A is your coefficient, b is your base. You should write this down. Ugly. There you go. That'll work. Okay. So b to the x. So right now I have this little slider thing, right? And b is equal to 2. So this right here that's being graphed is y equals 2 to the x. Okay. Now what happens as I make x, the base, a larger number? It is growing at a quicker rate, right? So versus, let's go back down, right? So here's 1.9, right, to the x. You see how it's kind of like, okay, nice little curve, great. But then as it grows quicker, it grows at a larger rate, a more exponential rate, right? It like shoots up like a rocket. Versus when we were here, whoop, 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 whoop. Here, this is more like a plane going off, not like fireworks, right? So here's like a plane, here's like straight up fireworks going up to the sky. Okay? Now, this is when, so I want you to pay attention to this number right here, b. So as b gets smaller and closer to 1, it gets flatter and flatter and flatter and flatter. When it's 1, it's flat. It's no longer exponential. B cannot be equal to 1 because it's not exponential. It's just constant. 1 to any power is 1, right? So now watch. What happens as it gets smaller and closer to 0? It surpasses 1 and it gets closer to 0. It's no longer, so here it was going from small to large, it's getting bigger. What happens as it hits between 0 and 1? It is now decreasing or decaying. Okay, you see how now the plane is landing instead of taking off, the plane is landing. So it's important to note. Now, as it gets closer and closer and closer to 0, it gets steeper. So now it's more like a plane crashing on the earth and not landing, but it's fine. But notice once we hit 0 or the negatives, the function just doesn't exist anymore. So it can't be negative, it can't be 0, and it can't be 1. But every other number in between 0 and 1 is decay. And every number greater than 1, it is growing. Okay, so let's look at what this a value does now. So let's go back to b equals 2 and a. Now, notice a can't equal 0 because then the function goes away. But if I have a equals 1, my y-intercept is 1. What happens when my a equals 2? Oh my God, so weird. My y-intercept, or my starting value when x equals 0, y equals 2. What happens when it equals 7? There's my starting value at 7. So it's important to know that my a value is my starting value, or my y-intercept. The reason, let's talk about why. When x equals 0, I have my y-intercept. We've spoken about that a lot, right? When my y-intercept means that x equals 0. Okay, so let's take this function right here and plug in 0. So if I have y equals ab to the x, and I'm going to say x equals 0. So I'm going to plug that into here. So I have y equals a times b to the 0 power. Anything, and we've spoken about this in class, excuse me, b to the 0 power. Well, we already know b is not 0. It has to be, it can't be negative, it can't be 0, it can't be 1. I'll write that here. B cannot equal 0, 1, or anything negative. And we spoke about anything to the 0 power is equal to 1, right? I'm going to write that here. Anything to the 0 power equals 1, except 0. 0 to the 0 power is undefined. So a times this becomes a 1. And so so y equals a times 1. What is a times 1? A times 1 is just y equals a. So what's important here? Actually, I'm going to put this in green because we had green up here. The important thing here is for every single basic exponential function, which is ab to the x, when x equals 0, y equals a. So the point that we have is 0, a. And that is my y-intercept. I'm going to write that here. So a is my y-intercept. Okay. So let's look at some functions. Because we kind of we'll revisit the a being the y-intercept. But we spoke about growth and decay. On my Desmos graph, we said that when b is greater than 1, right? Let's bring this back to here. When a was greater than 1, it still grew. No matter how close to 1 it got, it was still growing. But until it reached 1, right? So exponential growth is when b is greater than 1. And then I'm going to put the larger it is, the quicker the growth. So y equals 2 to the x. 2 is greater than 1, so therefore it is growth, exponential growth. What about this one? Y equals 3 to the x. My base is 3. 3 is greater than 1, so therefore it is also exponential growth. I'm going to put a number here. I have a 12 here. Now, this here is my coefficient. That doesn't change whether or not it is exponential growth or decay. This is just my y-intercept, or my starting point. This right here is my base, b. So b equals 1.1, which is still greater than 1. 1.1 is greater than 1, so it's exponential growth. Okay, what about this one? Now here, b is equal to 1/2. Is that greater than or less than 1? 1/2 is less than 1, so therefore it is exponential decay. And then this one also, 1/4 is less than 1. I was going to write out less than 1. So b is equal to 1/4, which is less than 1. And so it is exponential decay. What about this one? Y equals 0.9999999. This right here is still less than 1. Even though it's so close to 1, so close to 1, it is still exponential decay.